my brand new Lambo.
Take a moment to look at these two data sets. Now, typically when we're comparing two data sets, we look at the shape, center, and spread. When doing so for these two data sets, they are both centered around the number 3. They have a consistent range of 4, and they are both symmetric distributions. Though those two distributions look different, they are in fact both symmetric. So we're missing an element on how to describe the difference between these two values. Because though they are symmetric with a similar mean and range, the first one is bimodal, and its data is dispersed much more towards its extreme values, whereas the second data set has a much more consistent dispersion with its values centered close to the mean. So we need another measure for how to measure this dispersion or spread of the data across the distribution. Where measures of central tendency tend to tell us where the data is centered, it's possible for these two data sets to have the same mean but vary wildly in other respects. For that reason, we need to measure this dispersion, which is a measure of how centered or scattered the data set is. An example are these two distributions, the blue A and the red B. Both are centered in the same spot, whereas A is a much more dispersed or scattered distribution, and B is much more centered or consistent around its average. The measure of dispersion you're probably already familiar with is the range, which is just the difference of the highest and lowest value, but as we just saw, that's not the whole story. Another measure of dispersion we can use is the standard deviation, which is a measure of the typical or average distance an observation falls from its mean. It's represented with 2 letters depending on which form of standard deviation we're calculating. There's a Greek letter sigma if we're dealing with a population parameter, and a capital letter S if we're dealing with the sample standard deviation. So as a quick informal understanding of this standard deviation measure, if we look at two data sets, data set 1 and data set 2 in this example, which one would you expect to have the smaller standard deviation? Well, they both seem to have a center around 3, that's their median value, whereas dataset 2 varies more widely from 1 to 10 than dataset 1 does. So I would expect dataset 2, because its values vary further from its middle, to have a larger standard deviation. So how do we calculate this measure? So if I want to find the measures of dispersion for the dataset given here, I can find its range and standard deviation. Now its range we can calculate fairly directly. All I need to do is look at the smallest and largest value and take their overall difference. So in this case the range is 48. Now when we go to calculate the standard deviation, that's a bit more involved, so I'm going to use my calculator. If I go to the statistics menu and click edit, I can enter the values for my data set, which I've already done here in list 1. And to calculate the standard deviation, I can quit this menu, re-enter the statistics editor, press the right arrow to get to the calculation menu, and then one variable statistics is the option that I'm going to choose. In this case, I've already entered my data into list 1. I do not have a frequencies list, so I will erase that from the option, highlight calculate, and calculate my value. So this gives me a number of statistics. So I have the mean, which is here, is 34. And if I scroll down, I can see 2 measures for standard deviation. Now the one for the data set that I've entered is this S, because it is based on my sample of values from here. So this is S with a subscript X, which is 12.187. So I'm going to come over here, and my standard deviation is 12.19 when rounded to the nearest hundredth. One other variation of this calculation method would be if you are using a frequencies list. So here is another example. Say I want the mean and standard deviation of the data set summarized in this data below. What I'm going to do in this case is enter this information into 2 lists. I will put the data into list 1, so those would be my actual observations, and I'm going to put the frequencies into list 2 so that I have this entire frequency table and envision my calculator. To do that, I'm going to go to Stat and Edit. Now I've already entered them, but again, once you enter this data, you should have the frequencies in list 2 and the data in list 1. Once you've done that, you can quit out of the editor, pull up the statistics menu, press right arrow over to calculate, and again, I still only have one variable, so I'm going to pull up one variable statistics. The difference now is I now have a list of frequencies that I've entered from this frequency table in list 2, so I'm going to pull up second list 2 and enter that as my frequencies list so that my calculator knows that each of these observations occurs with that frequency. Now when I press calculate, I will get the mean, or the arithmetic average, and the standard deviation of the data set reported here. So I can enter that in my table. So I have a mean of 4.5 and a standard deviation of, oh, that should be 2.09. That is a typo. Should be 2.09.